Cast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you for joining today's webinar. Actually, this is Tuesday with SolidWorks webinar series, and I don't know if you are attending this webinar before, but we are conducting this webinar every week on Tuesday. So next week, of course, and during the whole month of June, we will be having this webinar. Hopefully that you can see the screen, you can hear my voice. If you do have any problem or any query, please let us know in the chat area. Today webinar, we will be speaking about combined simulation. There are a lot of information, tips and tricks, and actually we will start the journey from scratch. I'm having a special guest today from CAD/CAM team, Saleh Gad, but let me remind you with the main objective of this webinar series. So our objective, once we think about this webinar, is to stay connected with you. That's the main purpose. So whenever you are, if you stayed in home, or maybe you went to the site now, so we would like to be connected with you and give you a deep knowledge. So it will be more like a training. So for any product, so it will be more technical, and we are trying to listen to you, and please do not hesitate today. If you have any question, just throw the question through the chat area, even if it's not related to that today's topic. Let me introduce you to the company, to that VAR, value-added reseller that we are hosting today. It's a CAD/CAM team. They have been in the market since 2000, and they have providing the market with a lot of engineering solution. And we are in a great actually relationship with them, with a partnership with CAD/CAM team. We as the SO Systems, and CAD/CAM team today, they have more than 9 application engineers. 5 of them are elite application engineers. So some of you may be asking about what does it mean, elite application engineer? Actually, elite application engineer is like a title. So the one who gained that title, actually, he must go through a lot of exams, more than 14 exams, to acquire this title. So it's going to be in different areas: simulation, data management, inspection, quality control, manufacturing, even. A lot of areas are there to pass these exams and to acquire this title. And we have a special guest today, as I said, Saleh Gad. He's one of the elite application engineers in CAD/CAM team, and he will be taking us through the journey of flow simulation and simulation as well. So please stay tuned, stay focused. There are a lot of information today to share with you. And I will leave the stage to Saleh now. Saleh, you are good to go.
Thank you, Mr. Mutaz. Good day for all. Thank you for attendance. Today, we will talk about how to solve complex validation studies with SolidWorks software solutions, such like flow simulation solution or stress analysis simulation solution. So let's begin with the challenge today. The challenge is with Aviation Facilities Company. It's a leading company of designing complex products for accessory components for turbine engines. They have an issue for the delay of delivery of their components, and also modeling the complex turbine needs to have good prototype tests for designed products and the validating simulation process. Okay, so they consume time and material in prototyping for designed products and the validation process. With the integration of SolidWorks simulation products and within CAD product, they shorten the product design cycle and save the time. So let's see how we can achieve this integration. First of all, let's ask a question about how do you test your product design during the development cycle? Do you usually don't test them, or do you have a physical prototype, which means that you have a lab and extra cost and extra time for prototyping process, or you have an FEA analysis, a FEA analysis software, or a CFD analysis? What about if you have complex study that you need to achieve FEA analysis and CFD product and CFD analysis in one study? That what will we have to take today? Okay, SolidWorks simulation tools. SolidWorks simulation tools. Let's have a general discussion about what we can do with SolidWorks simulation tools. SolidWorks simulation solutions for SolidWorks provide an easy-to-use portfolio for analysis tool for predicting product real-world physical behavior, virtually testing the CAD model. What does this mean? That means you have a CAD model and you need to test this CAD model if it exists at the designed objective, or you need to remodel it or redefine it to be suitable for what you intend for your design. So you can subject your design to a real world condition to raise your product quality while reducing the prototyping and physical testing costs. SolidWorks simulation is an easy to use portfolio that you can have a large types of study that you can start with simulation standard package that you can test for stresses, and you can apply for a motion study and also a fatigue study. With simulation professional, you can go more professional and more, as we say, more smart with your component, such like you need to optimize your reshape, or you want to reshape the model that you design. Also, you can do a frequency and a drop test, and also topology test. Also, you can do a thermal analysis study within SolidWorks Simulation Professional tools. And within SolidWorks Simulation Premium, you get a larger data to be extracted in the simulation study, such like dynamics study. Also, nonlinear studies that you have a large displacement, or you have a nonlinear material, or you have high lateral strain in your study. You can apply your simulation premium tools to predict the actual stresses or actual strains or actual displacement or deformations, as we say, on your designed model. Okay, this is simulation tools. Also, we have another category for SolidWorks flow simulation tools. We will talk about it later, but let's talk about how do we use, or how can we do with SolidWorks simulation. SolidWorks simulation can solve for static analysis for parts and assemblies. You can apply a solid mesh for your CAD model, or a shell mesh for your sheet metal element models, or for your sheet metal models. Also, if you test a structure, such like this structure, you need to have a beam mesh. These varieties of mesh you can apply within a measure in SolidWorks simulation tool. Okay. Also, another common type of study, you can test for the weldments and spot weld for your structure. which weld will be safe, which weldment area will be safe, and which will not be unsafe. Also, you can solve for connectors, bolts, springs, and any other type of connector you want to simulate for testing what connectors actually behave in your design. For a SolidWorks Flow Simulation software is a powerful computational fluid dynamics CFD tool that enables the designers to quickly and easily simulate fluid flow, heat transfer, also fluid forces that are critical to the success your design. Okay, SolidWorks Flow Simulation is fully integrated within SolidWorks 3D CAD, such like SolidWorks Simulation. So you can use all of benefits for a fluid flow simulation to your design and your product design to get the better insight in your design. Design variation can be compared to make a better decisions, resulting in a product superior performance that you can use an optimization study to get which design that match your suitable needs for your design. So Dot Flow Simulation, you can, for example, you can simulate a water flow inside valve to dimension its pressure drop or velocity turbulences test, or you can also test for the airflow inside an electronic enclosure to optimize the cooling process, or check if you have a flow around vehicle. Simply you can do a check for the drag force and lift forces on that exerted on the vehicle while moving on the road. These are some examples of what capabilities of SolidWorks flow simulation. Okay, concurrent engineering helps detect design flow early in the design cycle that can help to compare which scenario are the best for your design or your intended situation. Also, we can combine for the SolidWorks simulation study and SolidWorks flow simulation study what will we talk about today within our case study today. Okay, in the SolidWorks flow simulation study that such like this picture, okay, we have in our case study, we will learn how to run a fluid flow simulation using SolidWorks flow simulation, where we will calculate the drag forces that exerted on this billboard sign. Okay, and finally, we need to predict what is the effect of these forces, these normal forces on the sign, and the point of view from the point of view of FEA analysis, or what are the deformations, what are the displacements, what are the strains that are exerted on this model when applying variant pressure due to variant velocity distribution through the domain or through the billboard. So we will solve this study with the two products, SolidWorks Flow Simulation and SolidWorks Simulation 2. With SolidWorks Flow Simulation, we can predict the force distribution or the pressure distribution or shear stress distribution, shear forces distribution on the billboard. So with this quantity of normal force that we can then move to SolidWorks simulation tool to predict what is the effect of these forces on this billboard, what are the maximum displacement, what are the maximum stress, also what are the maximum strain that exerted due to the flow of air. Okay, another type of studies that you can use this combination between flow simulation and simulation. That when you have thermal analysis within SolidWorks flow simulation, then you have to export those results to SolidWorks simulation for a thermal analysis study to know or to test what are the effect of the raising of heat on your model from point of view of a deformation or stresses or strain. Okay, let's start about supporting theory of SolidWorks flow simulation. Solving fluid flow problems is a difficult task. There are large gaps of knowledge in our understanding of a fluid flow. For example, governing equations for a fluid flow is one of important equations is a Navier-Stokes equation. Navier-Stokes equation is a very important equation when describing the pressure, the velocity, and the temperature of the and the external forces of the flow when you describe a mathematical expression for a flow. So when solving CFD analysis, you have a 5 equation of motions of the fluid or five governing equations of the fluid. One of them is called by Navier-Stokes equation. The Navier-Stokes equation, as you can see, it's partial differential equation that may have a number of or numerous number of errors or that you need a million times for iterations. So we can simplify this equation by describing that without doing in general solution of Navier-Stokes equation, as engineer must work with partial differential equation simplified. One way is to simplify this equation is calculate for a cube or that discretizing this domain to a cube, then discretizing the amount of temperature, the amount of pressure, the amount of external forces, that being able to calculate the fluid flow through a simple shape such like a cube or a brick leads us one step closer to calculate the fluid flow through the complicated shape, like gathering this inside manifold cells together. You can get the solution for all the domain. The entry of the cube that as we can say element, the entry of the element is pressure, and the exit of the element is a pressure and partial p per partial x dx. That with the SolidWorks flow simulation solver, you can predict the pressure drop variation from the inlet and the exit by combining these elements, as we can see, that you can give an actual solution for your complex domain within discretizing this domain. Okay. The collection of sample shapes, as we said, the collection of sample shapes, which we represent a more complicated shape, is known as a mesh. Each shape has known as an element. Fluid is calculated through element and flow through element influenced by the flow of its surroundings elements. This is the fundamental of CFD analysis. Okay. Our case study today, we will learn how to we intend to wind load often play a significant role when designing outdoor structures such as built sign. Okay, we will focus on how fluid flow load. Fluid flow load means that the forces exerted due to the movement of the flow of the air to predict the stress or a displacement and strain for structure. Okay, so we will create a fluid flow simulation using flow simulation.
Sorry to interrupt you here, Saleh. We have a question here. So can we apply the same methodology that you are going to show us on a tower or maybe a crane or any pillar standing against the wind, for example? And can we have the stress analysis out of that?
Any structure that I have a load that this type of load is a wind turbine, is a wind load, I can simulate for any structure that I have, such like a crane or a tower or a billboard. Just I have to check for the velocity of the air that surrounding this structure. Also the CAD model, so it's so easy to with these boundary conditions to get the actual pressure distribution on the structure, then predict for or solve for stresses in SolidWorks simulation tool. Okay.
So the answer is yes. Thank you, Salah.
Thank you. We will learn how to create a project using a SolidWorks flow simulation. These are procedures for here you can find the procedures for how to set up a flow simulation study. Then we will go through our case study to demonstrate how to run this study on your. Okay. First of all, we need to create a flow simulation using a flow study. Then the output study, then the next step is to prime the SolidWorks flow results for the compatibility with SolidWorks simulation. This is accomplished by or accomplished through export results to simulation feature that found in SolidWorks flow simulation tool. This step primes the FLD file as we will see. The FLD file is the SolidWorks results flow results file. It's where all post-processing data and for flow simulation is held. A simulation study then is created using a SolidWorks simulation. The simulation is set up by applying material properties, adding connections or fixtures and loads. To import loads from a flow study to a simulation study must be pointed by FLD file, as we can see in the next case study. The FLD file in software results that have a flow results that what will be a boundary condition in the SolidWorks simulation study case study. Okay. Let's open this part. Okay, we have this billboard. We will simulate we will simulate this aluminum billboard and find out how it holds up structurally to wind speeds of 40 meters per second. We will start by creating a fluid flow simulation study, clicking a feature wizard. Within wizard feature, you can describe the project name. Also, you can use any number of configuration if you any type of configuration if you have multiple configurations for this studies. This is the navigator list that shows you what are the steps you need to solve, you need to define to build up your project. Let's rename it a billboard study, and this is current configuration, and this will what will we run this study. Then I will select for a unit system SI unit system. Also, I can mix any combination between multiple systems, or can customize my own unit system that I will use for getting this study results. Okay. I can select a number of numerous quantities of unit system. Also, I can predefine my own unit system. Next thing is analysis type. In this study, we will solve for an external analysis. External analysis, that means the flow is bounded the flow bounds the model, not otherwise. Okay, and if I have a heat conduction solid solution, I can check this option. But in this study, we don't need to solve for a heat transfer. I'll check for the gravity. Okay. If you have heat transfer, it's important option. If you have a rotation impeller or such like turbine, and you need to to provide the accurate results for rotation. Okay, then for the default fluid, SolidWorks Flow Simulation lets you define up to 10 types of fluid in one study. In this study, we have one default fluid that will be the air. Also, you can predict or you can specify which is laminar and turbulent flow. It's important. in your study. In this study, we will select and laminar and turbulent study, as we not predict this quantity before starting our study. Okay, then the initial conditions, after applying the initial conditions, that will be the most initial conditions are near to the solution. If you aren't quite sure about the initial condition, just you need to define the velocity that in the negative x direction to simulate the air flow in the negative x direction with 40 meter per second axial velocity, normal velocity and negative x direction. If I have I can make a dependency and not just a constant velocity. If I have a function of the velocity, I can retype it. Finally, we build our domain. We build our project. This is a billboard project, as you can see. Then this cube is called a computational domain. Computational domain that will be discretized into elements, cube elements. And for this study, we need to just customize this domain by simplifying it or minimizing this domain to have a lower number of elements to get an accurate results with the same time and without sacrificing our resources for the machine where we run the results or sacrificing our time for study. So I will minimize this domain to be suitable for our study. Let's minimize the x direction. Also, if you have a 2D simulation, okay, you can apply for symmetric study. Okay, then let's apply our mesh. This slider is the level of initial mesh. The more and the higher slider means higher number of mesh, lower solution, more solution time and more accuracy. That in the first study, as we say, in your first setup, you need to run this study on the slider where it points for 3 or 4. Then for next studies that you have to apply a finer mesh to test your results and check that you apply the boundary conditions correctly. Okay. From here, we can define the goals. We need to calculate the normal forces, the forces that exerted on this face of the billboard. What will we export it in a FLD file to be used in a flow simulation in a simulation study. So we will solve for force of x. That means the normal forces that exerted on x direction, and what will we and let's call it a drag force. Okay, this is our goal in this study. Then let's move to applying our boundary condition. Our boundary condition is that we applied in the global defining this study, our study, as we defined the velocity and negative x direction equals 40 meter per second. So that we can have to also we can customize these tools by such like using customized tools, or let's now run this study and let's calculate a new calculation for this study. Also, I can specify number of cores to be used to run this study. Also, I have a batch results option to be run in another machine. Okay. As you can see, the solver window opens, and here is the information bar. The information bar will show you the status of meshing, the total sales, and this is a crop tools or a cross section for the velocities. Okay, this is a goal plot. The goal is to a drag force after balancing or after number of iterations. As you can see, this is a billboard, and this is accurate variation of the velocity distribution on this sign. The maximum velocity is, as you can see from this plot. Okay, you can save a real-time video. Okay, that you need this results in post processing. This video can be a very powerful tool for powerful media for reporting. Okay, then let's define or let's hey, you can achieve this. The solver is finished, and this is the maximum force or the maximum drag force in the negative x direction. Now let's see how to post process our results. This is folder, the results for, sign for one FLD file, one.fld file. That's where the results are saved. That what will we need for the next step is to solving for a simulation study. Okay, but first let's create a cut plot to see the pressure distribution through the normal face or the plane that are parallel to the screen. Okay, to see the pressure distribution, I will see the streamlines. If the streamlines are the contours where the flow particles are moving through the domain, and I will show for the distribution of the velocity through this section or this cut plot. As you can move this slider for more fine tuning the coloring bar, your color bar here. And these lines, if you have a powerful graphics card, you can when zooming in you can see more details about where the flow enters and exits the domain. You can see for where the eddies and shadings and pressure drops due to eddies can find in your domain by zooming in and out your 3D model. Okay, and we can play a motion of animation cut plot to see the velocity distribution through the cut plot through the global domain of the results. Okay, here you can apply for a cut plot. Then for a flow trajectories, let's create a flow trajectory to show the trajectories of the air particles that entering and exit this domain or that hitting the billboard sign. Let's define number of particles, that will be 50. Okay, then let's run for a flow sim. Let's play these particle trajectories. The more number of trajectories, the more insights to your study to get more results about your design. Okay, let's hide the flow trajectory. Then let's show our goal. The goal for this study, as we checked in the goals, is a drag force. Let's see. Let's export it to Excel and show the variation of this goal. As you can see here, you can find the maximum drag force in the negative x direction. Also, I can export it to an Excel sheet that shows the value distribution, the drag force distribution during the number of iterations till the conversions complete in the solver. Okay, this is number of iteration versus drag force value. For this, we solved for flow simulation study. Then we need to export a flow results to a simulation study. Now we have to import the loads from the flow study. The simulation study must be pointed to the FLD file. This is where in a static simulation study, where what will you call for the one FLD file or FLD file that you just saved from the flow simulation study. This is done by a feature called flow thermal effects in SolidWorks simulation tool. It's flow as in this case study, and thermal studies such like heat sink, as we talked earlier. To if you want to predict the 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 model or the stresses effect or the deformations effect due to increasing or decreasing the temperature of computational domain. Now let's export the results. As you can see, this is a result folder, one.fld file. This FLD file, let's navigate to the case study folder path. And as we can see, this is the folder we need to point in a SolidWorks simulation solver. Okay. As you can see, these are the videos that saved in while running this study. Then now let's go for flow simulation, and then from tools export to simulation results. There's a message that the transferring occurs successfully. Now, if I need to specify what type of results I need to export, I can check for export results and check what type of result I need to I need to export in the next study. Okay. And in our study, we only have a goal for drag force in X direction. Okay, so we exported now the results. Then let's go for defining how to solve for stress results. Once the simulation add-in is activated, we will create static linear analysis. Then we will apply a material properties for aluminum alloy to the structure. Next, we will import the structure loads effects from the FLD file. Then we will apply a fixture to the base of the billboard to simulate the ground holding the structure from moving. Next, we will mesh our geometry. Finally, we will run the structure analysis and get the results for stresses and strain and displacement. These are the procedures for how to solve a stress analysis study. First of all, apply material. Second, apply fixations and boundary conditions. Finally, apply your loads. Some of them are fluid flow loads, such like our webinar today, or something like external forces or external effect that affects on the stresses on your model. By defining your study, meshing, then post-processing your results, you can predict for the stresses and the stress distribution and the displacement distribution through the model. Now, let's go for a simulation study, then click new static study. As we said, there are a number of types of studies. Today, we will solve for a static study, which means that you have small displacement study and linear material such like aluminum study. Okay, apply the material, then fixation, then external loads, then connection if you have, then run, finally export your report. Within few clicks, you can create a fully intuitive report about your case study. Okay, let's select the aluminum alloy in our material. These red values are critical for this type of study, such like mass density, yield strength, elastic modulus, and Poisson ratio. Okay, the check mark from the left menu means that you applied the material correctly. That we will now define the fixation, where the plate or the billboard is grounded to the ground or welded to the ground by applying a fixed geometry. That means this face will not have any type of degree of freedom, that you have a 6 degree of freedom. All of them are locked. The translation and the rotation about the three coordinate system are locked in this type of fixation. Now we will point for a flow effect of loading, then flow thermal effect, then select the option for fluid pressure option and include the FLD file. As you can see, browse and select this folder. Okay, also you can select the configuration and the reference pressure that you or the datum where you define the product, the pressure in this study. As you can see, this file is extracted to the fluid shear stress and the three coordinate system x and y and z. Finally, now let's pre-process in the pre-process stage, that we will mesh our model to a cubic element or to a tetrahedral element. As you can see, these elements will be solved for stress equation or second law of motion of Newton motion, that sigma forces, the sigma of external forces equals K, which means by stiffness, multiplied by displacement or X, the deformations occurred in during to these external forces. As you can see, here you can find the von Mises stress distribution due to external loads of a fluid shear stress in X and Z and Y and Z directions. This plot is for stress distribution, and here you can find the maximum stress that what will be exerted will be this value. Okay, and we can show the minimum and maximum annotation to see where is the maximum stress exerted on the model. Okay, and still also you have this point of yield strength. Okay, now let's show for a displacement. This is the maximum displacement occurs due to external forces. As you can see, this is the maximum displacement for 2.6 millimeter due to wind load. From here, you can decide if this study or if this material or of this boundary condition are suitable for your sign or not by using the stress distribution and check for the factor of safety, also the design stress or the factor of safety where you define the maximum stress of your study. Okay. Let's arrange some these annotations. Then, as you can see, this is the yield strength and maximum von Mises strength. Now, let's go for create our report. Select the sections what you need to show in the report, and select the header information such like designer, company, or logo and address. That what will be published in just a few seconds. Let's apply and then publish our report. As you can see, it's fully intuitive and fully detailed report for numerous sections, such like model information, such like number of solid bodies, such like study properties and type of fixation and type of contacts, type of mesh that you used. Then you can solve for reaction forces or reaction moments, or if you have a beam study that you can get these moments. Finally, you can see here the results, and you can select and you can type then the suitable conclusion for your design, that you can show these external forces are given from a flow simulation study, then exported to a simulation study. So finally, let's summarize what we show in the study. We used a flow simulation to solve for pressure distribution from a wind on a billboard. We then used this pressure distribution to run a linear static analysis and SolidWorks simulation to study the response of the structure due to the external forces. The flow simulation gives us the opportunity to export results pressure or temperature, even convection loading to a SolidWorks simulation for a linear static analysis. From here, we can further evaluate the response of our structure. So, the benefits that the aviation facilities that have from implementing or deploying the SolidWorks CAD integration with SolidWorks simulation and SolidWorks flow simulation, they improve the quality, then you can increase the performance, which will leads you to reduce the number of prototypes and use the less material for prototyping. And as you can see, the easy of use and the fully integration with the CAD model and the flow simulation results, or within the simulation results. Okay. From now, I have finished what we did in the webinar today. So if you have any question about this case study or this webinar, I'm glad to hear your questions right now.
Thank you so much, Saleh. I believe we get a lot of information from Saleh today regarding the integrated solution between CFD and FEM. And we are here for you. So we can give you a few minutes. If you do have any question, any doubt, even we can open a mic for you for further discussion. So please let us know if you do have any question, even if it's related to simulation plastic, that's fine. So please do not hesitate to throw the question. Okay, we have a question here. Does fatigue analysis included in simulation standard or not? Can you give some insight about this question, Saleh, please?
Okay. The normal fatigue plot is founded in a simulation standard, but for more complex fatigue types of loading, such like complex loading or non-periodic loading, you can move for more professional solution for fatigue input boundary conditions. You can go through SolidWorks Simulation Professional software.
Okay, great. Another question, Saleh. Can we do some optimization through flow simulation?
Yep, sure.
Can the SolidWorks flow simulation advise us with the right solution to choose?
For sure, just pick up the dimensions or the model reference that you need to optimize for, then select the scenario and the goal for optimization. Then the scenarios will be run automatically to get the best scenario for the best optimization.
Okay, another question here. Is there any limitation to solve a problem with SolidWorks flow simulation regarding the model size, the design size?
The design size, We have, fortunately, as the design size more larger, we have more time consuming, but we have tips and tricks features that will be very effectively when solving for large studies, such like a feature called EFD zooming. EFD zooming feature that solve for the global domain with a global mesh, with a global coarse mesh. Then you can specify a small area from the domain that you can apply a denser mesh or a more quality mesh in this area. Such for these studies, you can solve for a large design study with number of elements, but giving you an accurate solution for most important area in your design concept.
Okay, another question. I think this question for me. Can you share the video recorded session, please? And the answer, of course, yes. We're gonna share the recorded session, of course. Yeah. I think no more for question. And again, I would like to thank you all. I think there is another question. Can we make the study of the same model in case of modeling it using master modeling, multi-bodies? So the question is, can we use multi-bodies in flow simulation, Saleh? Can you please give us some insight about that, or maybe assembly?
For sure, you can, such like if I have a thermal study for an electronic enclosure, I have multiple types of materials in the electronic enclosure. Even if they are designed in assembly way or a multi-body way, I can select or predict or define a boundary condition for a one body or a one face or a one part or even a one even a number of type of bodies or solid bodies. I can apply for even a part or a solid body or a feature or a face within the model.
So this will be applied also for flow simulation, right, Saleh?
Yeah.
So we can have multi-body, we can have assemblies in a flow simulation problem, right?
Yes, for sure.
Okay, I think that's it. I don't have more question in the list. Okay, perfect. Again, thank you all for attending and having the time with us today. And we're gonna be waiting you next Tuesday for the upcoming webinar in our webinar series. Thank you and have a great day today. Goodbye.